So this is task 3 for standards algebra. The first thing we're going to do is look at order of operations. You should have seen this. This should be review, but we're going to go through it nice and slowly. The order of operations gives you an algorithm for evaluating expressions, both numerical expressions and expressions with variables. We're going to be talking about variable expressions later on in this lesson. The first thing you do when you're evaluating an expression is to evaluate expressions inside grouping symbols. And so let's discuss what a grouping symbol is. The first one most people think of is parentheses, and parentheses is the reason for the P in PEMDAS. Some of you may know PEMDAS as a way to remember the order of operations. Please excuse my dear Aunt Sally, or some people say GEMDAS or GEMDAS, the G standing for grouping symbols. Another grouping symbol would be the square bracket, which pretty much has the same function as parentheses. Absolute value symbols. Those are a grouping symbol. And another one we sometimes forget about is the fraction bar. You want to evaluate an expression in the numerator and your expression in the denominator before simplifying if you're using the order of operations. So let's put fraction bar so you remember what that is. Okay, so we have parentheses or grouping symbols. We have our exponents. That's what you evaluate after the parentheses or the grouping symbol. And then after that, look, I have a little typo, you evaluate multiplication and division. And you do that from left to right. No matter which order the multiplication and division symbols are in, you evaluate them from left to right. So multiplication and division. And similarly, next is addition and subtraction at the same time, but from left to right. So let's give that a try so we can see exactly what we mean by that. So if we look at this first example, there are no grouping symbols, there are no exponents, so the next thing we'd want to do would be multiplication, and there is a multiplication. So this equals 18 minus 6 plus 5. Now, next there's addition and subtraction, and what I know is that neither of those comes before the other. I just have to work from left to right. So I'm going to say this is 18 minus 6 is 12 plus 5 equals 17. Now notice in this next problem the numbers are the same. We've just changed it by adding some parentheses. And if you look over at the U-try over here, we've added parentheses in a different spot and some square brackets. And what's interesting is to see how that changes the order of operation and therefore changes the value. Okay, so what would we do first here? We would do the grouping symbol. So that gives us 16 times 3 plus 5. Next is multiplication. So we have 48 plus 5, and 48 plus 5 is 53. Okay, if you're watching the video, go ahead and pause and do the U-try. And the U-try, when we evaluate within a grouping symbol, we still apply the order of operations. So within this grouping symbol, we're going to do this grouping symbol first. So this is 18 minus 2 times 8. Then we do the next grouping symbol, 18 minus 16, which is equal to 2. So all of these have the numbers in the same order, but for all of them we get a different result depending on where the parentheses are. Okay, now a variable expression. A variable expression is simply an expression that contains one or more variables. And we're going to look at what we mean by that. So if a CD or a song that you upload costs $15, I guess that would be at least a whole album, and you buy 2, then the total cost is 15 times 2. Now notice that means 15 times 2. Once we start working in algebra, we don't usually put the times symbol, the multiplication symbol, unless there's a good reason to. If you can use parentheses, that's preferable. So here's a little table. If I bought 2 CDs, as we noted, the total cost is 15 times 2. If I buy 3 CDs, the total cost is 15 times 3. If I buy 8 CDs, the total cost is 15 times 8. 12 CDs is 15 times 12, and so on. So what would be the cost of n CDs? It would be 15 times n. So if the number bought is n, then the total cost is 15n, which means 15 times n. A symbol, which is typically a letter used to represent one or more numbers, is called a variable, and in this example n is the variable. Okay. An expression consists of numbers, variables, and operations. Expressions such as 15 times n in the example above are called variable expressions, as we mentioned before. Now, what we're going to do is rewrite each of the following expressions. 7n means 7 times n, and you can use a little x or you can use a dot for your multiplication symbol. Now, what about a squared? A squared means a multiplied by itself. So a squared is a times a, and then this is plus 2. A times a plus 2. So we're just deciphering what the mathematical language means. So here's a you try, so go ahead and pause your computer and you give it a try, and then when you come back you can see how I worked it out. Okay, so in this case y squared is y times y, but we also have the 6. So this is 6 times y minus 16. Okay, now we're going to look at the individual terms within an expression. Sorry for the... Okay. The terms in an expression are separated by pluses and minuses. Here's an example. Here's an expression. Just this part of the expression involves multiplication. That doesn't separate terms. Only pluses and minus separate terms. So this is a term, this is a term, and this is a term. But if a term has no variable, it's just a number, then it's called a constant or a constant term. It's a term and it's a constant. The number multiplied by a variable, and here's a number multiplied by a variable, here's another number multiplied by a variable, those are called coefficients. So that's just a little bit of vocabulary, and our exercises here are going to test what we understand about our vocabulary. Name the number of terms. That's part A. So I see 3 terms. Identify the terms. Well, 5x cubed. Negative 3a. This negative is always part of the term that it's in front of. And then 2. Identify the constants. Well, only one of them is a constant. That would be 2. And identify the coefficients. That would be 5 and negative 3. All right. Name the number of terms in this one. Well, there's just one term. There are no pluses or minuses. So just one term. The term is 12abc squared, c. Identify the constants. There are none. And d. Identify the coefficients. That would be 12. So it's the constant that's in front of, or the number that's in front of the variable or variables. Okay, so go ahead and pause your computer so that you can do the U-try. All right, so how many terms? 1, 2, 3, 4. And name them. Negative y, remember the negative is part of the term. X. negative 2z, and 7. Identify the constants. There's just one, it's 7. And name the coefficients. Okay, what's the coefficient for negative y? What's multiplied by y here? Oh, it's negative 1. Is there a coefficient for x? Of course, it's 1. It's not 0 because 0 times x is 0. So it's 1. If you see a variable all by itself, its coefficient is 1. Negative 2. Those are our coefficients. All right. Now we have like terms. Now look at this expression. We've got some x's and y's. Like terms are terms that we can combine later on when we're evaluating expressions or simplifying expressions. Like terms have the same variables with the same exponents. So let's take a look here. I've made a note that these are like terms. They have the same variables. They both have an x and a y, and the y's both have are squared, an exponent or a power of 2. So these are like terms. Now, is this a like term with those? No, because the y isn't squared in this one. And this one doesn't have an x, so it's not a like term. So let's take a look down here. Okay, so the ones with like terms, they have to have the same variable, so these do, with the same exponent. Well, these have an exponent of 1, we just don't write it. So these are like terms, 6b and b. Now what about the 3 and the 1? They have the same exponent, they don't have an exponent, they're both constants, so they are like terms. We know we'll be able to combine those and add them together. So those are like terms. Now what about this one? We have 12xy minus yx. Are those like terms? They don't look the same. Oh, but wait a second. Both have a y and both have an x. And the x and y have the same power in both. And we know that multiplication is commutative, so really this is the same as subtracting xy. So those are like terms. Same variable, same exponents. xy and negative yx are like terms. Okay, go ahead and pause so that you can do the U-try. All right, let's take a look at this.